We'll start in about 1 minute. Today we'll start section 9.6 on graphing quadratic functions. So we start out, we let the variable y be a quadratic function of the variable x. Then its standard form is y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The graph of a quadratic function, that is the graph of y equals ax squared plus bx plus c in the xy plane, is a parabola. If the number a is positive, that's the coefficient of the x squared term, then the parabola opens up. And if a is less than 0, then the parabola opens down. So a couple of pictures. In the xy plane, we could have a parabola that looks something like this. So that's supposed to be a parabola. And in this picture, since the parabola opens up, the coefficient of x squared has to be positive. Every parabola has a vertex. If the parabola opens up, then the vertex is the lowest point on the parabola. And there's a, well, I'll get to that in a minute, but in the other case, if you have a parabola that opens down, that means that the coefficient of x squared is negative. That is, a is less than 0. And for a parabola that opens down, the vertex is the highest point on the parabola. Okay, we have a formula for finding the x-coordinate of the vertex. So for the graph of y equals ax squared plus bx plus c, the x-coordinate of the vertex is x equals negative b over 2a. And the vertical line of symmetry is the vertical line x equals negative b over 2a. So the vertical line of symmetry, it's not really part of the graph. We just think of it as the vertical line that passes through the vertex. The equation for that vertical line, we've seen equations of vertical lines before. So the equation of that vertical line is x equals negative b over 2a. And the x-coordinate of the vertex is the same number, negative b over 2a. And we could write the formula for the y-coordinate of the vertex, but in general, it's easier just to use negative b over 2a to find the x-coordinate. And then to find the y-coordinate, just use the function and replace x with negative b over 2a. Okay, so make sure you know what the line of symmetry is. It's the vertical line of symmetry. And every parabola has one. So it's called a line of symmetry because the right side of the parabola is a reflection of the other side of the parabola. We can also say that the parabola is symmetric with respect to the vertical line of symmetry. And another way to describe it is essentially what I've already done. One side is a reflection of the other side, like a mirror image. So every parabola in the xy plane has a vertical line of symmetry, and the equation for that vertical line of symmetry is x equals negative b over 2a. Every quadratic function, y equals ax squared plus bx plus c, has a y-intercept. The y-intercept occurs when x is 0, and so the ordered pair for the y-intercept is 0, c. And you can see from the quadratic function, when you replace x with 0, you're left with y equals c. Okay, so in this picture, that is the y-intercept. That's the point on the y-axis that the parabola crosses. So the ordered pair is 0c for the y-intercept. In the other picture, the y-intercept is right here, 0c. Well, regarding x-intercepts, the place on the x-axis that a parabola crosses, well, one of three things will happen regarding x-intercepts. The graph of a quadratic function in the xy plane, it may have two x-intercepts, one x-intercept, or no x-intercepts. So we'll sketch a couple of graphs. Oh, if you have a parabola that opens up, and is entirely above the x-axis, then there are no x-intercepts. Another way that you could have no x-intercepts is if the parabola opens down and is entirely below the x-axis. So this also has no x-intercepts. Well, since I'm running out of space, I'll just do one case of each. A parabola could have two x-intercepts. If the parabola opens up and the vertex is below the x-axis, then it has two x-intercepts. And also if you have a parabola that opens down, and if the vertex is above the x-axis, that will also have two x-intercepts. All right, then there's one more possibility. The first two possibilities, no x-intercepts, two x-intercepts. What's the third possibility? A parabola could have one x-intercept. So what does that mean if there's one x-intercept?
The highest or lowest point is on the x.
Right. Yeah. If there's exactly one x-intercept, then the vertex is on the x-axis, and so the vertex is the same as the x-intercept. If the parabola opens up, then the vertex on the x-axis is the lowest point. So this graph has one x-intercept, and it's also the vertex. Or you could have a parabola that opens down, and the vertex being the x-intercept would be the highest point on the x-axis. Okay, in general, how to find the x-intercepts. This will be a similar concept. Earlier this semester, we had a number of sections on linear functions, the y equals mx plus b functions. And we learned how to find the x and y intercepts of a linear function. And some of those ideas carry over to quadratic functions. So here's a statement. To find the x-intercepts, if there are any, replace y with 0 and solve the resulting quadratic equation for x. So if we begin with the quadratic function y equals ax squared plus bx plus c, to find the x-intercepts, replace y with 0, and then solve the quadratic equation that results. Okay, that's what we spent some time learning how to do for a few days, solving quadratic equations. So why do we replace y with 0 in order to find the x-intercepts? There has to be a reason. Why do we replace y with 0?
Because when you're writing the order in pairs, the x-axis point has 0 in my place.
Yeah, the answer is every x-intercept has a y coordinate that's equal to 0.
Way less.
Yeah, every point on the x-axis has a y-coordinate that's equal to 0. So if you want to find the x-intercepts, you replace y with 0 and solve for x. Does that make sense? That's the same statement that we made when we were finding the x-intercepts of linear functions. Replace y with 0 and solve for x to find the x-intercepts. Okay, so when we graph a quadratic function, y equals ax squared plus bx plus c, well, we find a few points and plot the points and then draw a parabola through the points. But in the abstract, the graph of y equals ax squared plus bx plus c consists of infinitely many ordered pairs of the form xy. We don't have time to find infinitely many, so we find a few of the ordered pairs and then sketch the graph of a parabola that passes through those points. Okay, so my advice is think of y equals ax squared plus bx plus c as a formula for finding the y-coordinate of an ordered pair xy that goes with a chosen x-coordinate. So we can pick any number, any real number for the x-coordinate. And then after we pick the x-coordinate, we replace x with that number to find the corresponding y-coordinate. And then we can plot that ordered pair in the xy plane. Usually we try to pick x and y coordinates that are near the vertex, some points to the left of the vertex itself, and then points to the right of the vertex, so that we can sketch the graph of the parabola in a somewhat accurate way. Okay, so we're going to look at a bunch of examples using this idea. Think of y equals ax squared plus bx plus c as a formula for finding the y-coordinate of an ordered pair that goes with a chosen x-coordinate. And we'll also use the vertex formula for the x-coordinate. The x-coordinate is x equals negative b over 2a. And then for x-intercepts, I'll just refer to what is stated above. Replace y with 0 and solve the resulting quadratic equation for x. And also find the y-intercept when x is 0. The y-coordinate will be equal to c. So use the vertex formula, find the x and y intercepts. And then you can sketch a graph of the parabola after that. Okay, on the next page, we'll start out with the most basic quadratic function, y equals x squared. Okay, graph the quadratic functions by plotting points, identify the vertex, the x and y intercepts, and the line of symmetry. Okay, so y equals x squared A is 1, B is 0, and C is 0. If you think of y equals ax squared plus bx plus c, then for this one, y equals x squared, there is no x term, so b has to be 0. There is no constant, so c is also 0. Okay, so what's the vertex? The x-coordinate of the vertex is negative b over 2a. But since b is 0 and a is 1, we get 0 divided by 2a. So the x-coordinate of the vertex is 0. Then use the function to find the y-coordinate. When x is 0, the y-coordinate is 0. So the vertex is the ordered pair 0, 0. So remember, every point in the xy plane corresponds to an ordered pair. It's never just a single number. It's a point that has an x-coordinate and a y-coordinate. Okay, the x-intercept. Well, every x-intercept has a y-coordinate that's 0. So replace y with 0 and solve for x. The x-intercept is the same as the vertex. And the y-intercept, well, when x is 0, the y-coordinate is also 0. Okay, so the point 0, 0 is not only the vertex, it's the x-intercept, the only x-intercept, and it's also the y-intercept. Okay, another strategy for finding points on the xy plane is to create a table of ordered pairs. And one strategy, if you know what the vertex is, what the x-coordinate of the vertex is, then oftentimes what I'll do is I'll pick 5 x-coordinates, and the middle one will be the x-coordinate of the vertex. And I'll pick a couple of numbers, a couple of integers less than 0, like -1 and -2, and then a couple of integers greater than 0, like 1 and 2. Then I'll use the quadratic function as a formula for finding the y-coordinates. So we begin with x equals -2. When x is -2, the y-coordinate that goes with it is -2 squared, which is +4. When x is -1, the y-coordinate that goes with it is the number -1 squared, which is 1. When x is 0, y is 0 squared, or 0. And when x is 1, the y-coordinate is 1 squared, or 1. And when x is 2, the y-coordinate is 2 squared, or 4. So I'll try to squeeze the graph in right here. So -2, -1, 0, 1, and 2, 1, 2, 3, and 4. So the ordered pair -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then sketch the parabola that goes to those points. So the parabola goes on forever in the two directions, but that's what is implied by those arrows. Okay, let's move a little faster. On this one, y equals negative x squared. We can tell by looking that the vertex is the ordered pair 0, 0. So if I use the same x coordinates, negative 2, negative 1, 0, 1, and 2, and then we have to make sure we're careful with the arithmetic. When x is negative 2, here's the formula for the y coordinate. The y coordinate is the negative of the number negative 2 squared. So first we compute negative 2 squared, which is 4, and then we take the negative of that to get negative 4. When x is negative 1, the y coordinate is the negative of the number negative 1 squared. So the order of operations, the negative 1 squared is 1, and then we take the negative of 1 and we get negative 1. When x is 0, negative 0 squared is 0. When x is 1, the y coordinate is the negative of 1 squared, or negative 1. And when x is 2, the y coordinate is the negative of 2 squared, or negative 4. Okay, so we plot the ordered pairs in the xy plane. Somewhat accurately. So maybe we should get into the habit of labeling the ordered pairs, or at least a few of them. So the vertex is 0, 0. This point is the ordered pair 1, negative 1. Over here is negative 1, negative 1. This point is 2, negative 4. And this point is negative 2, negative 4. The vertical line of symmetry is x equals 0. It's the line of symmetry. And both the X-intercept and the Y-intercept is the ordered pair 0, 0, which is also the vertex. Okay, those are the two basic parabolas, one that opens up and the other one that opens down. And all other parabolas can be found by starting with one of those two. Hey, let's look at the next example, y equals x squared plus 1. So before plotting points, what can you say about the parabola that we'll graph, whose equation is y equals x squared plus 1? Or maybe to make it more clear, how does the graph of y equals x squared plus 1 differ from the graph of y equals x squared? The equation itself tells us what the graph of y equals x squared plus 1 is relative to the graph of y equals x squared. So if we took all of the y coordinates from y equals x squared and then added 1 to those y coordinates, what's the graphical effect? The graphical effect will be a vertical shift upwards. Okay, but even if you don't notice that, you can still graph the quadratic function by plotting points. So if we find the x coordinate of the vertex, x equals negative b over 2a. So on this one, a is 1, b is 0, and c is 1. So the x coordinate of the vertex is 0. And so the vertex, what is the y coordinate of the vertex? Well, when x is 0, the y coordinate is 0 squared plus 1, or 0, 1. So if you use my strategy, we found that the x coordinate of the vertex is 0. So I'm going to pick 5 ordered pairs, and the middle x value will be the x coordinate of the vertex. And then we'll pick a couple of integers less than 0 and a couple of integers greater than 0. And then we'll use the formula for finding the y coordinates that correspond with the x coordinates. Okay, so when x is negative 2, what's the y coordinate that goes with it?
5.
Yeah, it's 5. The number negative 2 squared is 4. 4 plus 1 is 5. When x is negative 1, the y coordinate is the number negative 1 squared plus 1, which is 1 plus 1, or 2. We already know that we have the ordered pair 0, 1. And then when x is 1, the y coordinate is 1 squared plus 1, or 2. And when x is 2, the y coordinate is 2 squared plus 1, or 5. So if we plot those points, we can at least give a reasonably accurate graph of the parabola. The ordered pair negative 2, 5. The ordered pair negative 1, 2. The ordered pair 0, 1. The ordered pair 1, 2. And the ordered pair 2, 5. And then we can draw the parabola that goes to those points. So my graph is not very accurate. It doesn't look like it's symmetric with respect to the y-axis, even though it's supposed to be. And then plot the ordered pairs 2, 5, 1, 2, 0, 1, negative 1, 2, and negative 2, 5. So observe that there are no x-intercepts. no x-intercepts. But we always have a y-intercept. The y-intercept occurs when x is 0, and 0, 1 is the y-intercept, and it's also the vertex. Okay, the next one, y equals x squared minus 1. The relationship between the graph of y equals x squared minus 1 and the graph of y equals x squared, well, both parabolas open upwards, but the graph of y equals x squared minus 1 can be found by taking the graph of y equals x squared and moving that graph vertically downward by 1 unit. We'll learn more about transformations like vertical and horizontal translations or shifts in a couple of days. But for now, we're just learning how to use the function as a formula for finding y coordinates whenever we pick an x coordinate. Okay, the vertex on this one So what's the ordered pair for the vertex on this one?
0, -1.
Yeah, 0, -1. So the x-coordinate of the vertex, negative b over 2a. Since b is 0, that's the x-coordinate is 0. And then when the x-coordinate is 0, use the formula, if you have to find the y-coordinate. Y is 0 squared minus 1, or -1. So the vertex is 0, -1. Also notice that 0, -1 is the y-intercept, because every y-intercept has an x-coordinate that's equal to 0. All right, so if we pick x-coordinates, you can pick more than 5 ordered pairs if you want, but I'm going to pick 5, and my middle x value is going to be the x-coordinate of the vertex. So I'm still using the same x-coordinates, -2, -1, 0, 1, and 2. And then to find the y-coordinates, I'm using the function as a formula for finding the y-coordinates. When x is -2, the y-coordinate is the number -2 squared minus 1, or 4 minus 1, which is 3. When x is -1, what's the y-coordinate?
0.
Yeah, 0. The number -1 squared is 1. 1 minus 1 is 0. And when x is 0, the y-coordinate is 0 squared minus 1, or -1. We already knew that. That's the vertex, 0, -1. When x is 1, the y-coordinate is 1 squared minus 1, which is 0. And then when x is 2, the y-coordinate is 2 to the second minus 1, or 4 minus 1, which is 3. Okay, we know the vertex. We know the y-intercept. Before graphing, let's find the x-intercepts. So what are the x-intercepts?
-1, 0, and 1, 0.
Yeah, we already found the x-intercepts. Remember that when y is 0, then the ordered pair is the x-intercept. So -1, 0 is one of the x-intercepts, and the other x-intercept is 1, 0. Notice, though, if we didn't notice that, how would we go about finding the x-intercepts?
Parabola crosses the x.
Yeah, to find the x-intercepts algebraically, we replace y with 0 and then solve for x. So replace y with 0, we get 0 equals x squared minus 1. And then we solve this equation. We can solve this one by factoring. One factor is x minus 1 and x plus 1. Okay, so when we solve for x, we get x equals 1 and -1. And we already know that the y-coordinate of the x-intercepts is 0. So 1, 0 and -1, 0 are the x-intercepts. Yeah, I know we're overkilling it, but the details might be useful in the long run. Okay, so we'll plot a few of these points. Okay, so -2, 3, -1, 0, 0, -1, 1, 0, and 2, 3. So plot the ordered pairs 2, 3, 1, 0, 0, -1, -1, 0, and -2, 3. All right, let's do the next two. Y equals -x squared plus 1. So we already graphed y equals -x squared. So up here we graphed y equals -x squared. That is a parabola that opens downward, and the highest point, or the vertex, is at 0, 0. So we could get a graph of y equals -x squared plus 1 from the graph of y equals -x squared if we did what? So think of it this way. The y-coordinates on the graph of y equals -x squared plus 1 are 1 more than the y-coordinates of the points on the graph of y equals -x squared. So the graphical effect is taking the graph of y equals -x squared and shifting it vertically up 1 unit. Okay, that's nice to know, but if you don't know it, you could still get a graph of the function by plotting points. The vertex of this graph let's see, the x-coordinate is negative b over 2a. Well, since b is 0, the x-coordinate of the vertex is 0, and the y-coordinate is 1. So we'll pick a few x-coordinates, use the function as a formula for finding the y-coordinates. So we'll pick negative 2, negative 1, 0, 1, and 2 for x. When x is negative 2, the y-coordinate is the negative of the number negative 2 squared, which is negative 4, and then negative 4 plus 1 is negative 3. Then when x is negative 1, the negative of the number negative 1 squared is negative 1. Negative 1 plus 1 is 0. When x is 0, y is 1. When x is positive 1, the negative of 1 squared is negative 1. Negative 1 plus 1 is 0. And then when x is 2, the y-coordinate is negative 4 plus 1, or negative 3. Okay, so we'll plot those points. Okay, so negative 2, 3. Sorry, negative 2, negative 3. Negative 1, 0. 0, 1. 1, 0, and 2, negative 3. Okay, in the process, we found the X-intercepts and the Y-intercept, which is also the vertex. So we'll get into the habit of plotting points as ordered pairs. Okay, let's graph the next one. We have a little bit more than 2 minutes left. Okay, so the x-coordinate of the vertex is 0. So I'm still using the same x-coordinates, negative 2, negative 1, 0, 1, and 2. Tomorrow we'll graph quadratic functions that will pick different x values. Okay, so when x is negative 2, the number negative 2 squared is 4. Negative 4 minus 1 is negative 5. When x is negative 1, negative 1 squared is 1. Negative 1 minus 1 is negative 2. When x is 0, negative 0 squared minus 1 is negative 1. When x is 1, negative 1 squared minus 1 is negative 2. And when x is 2, negative 2 squared is negative 4 minus 1 is negative 5. Okay, plot the points, negative 2, negative 5. Negative 2, -5, -1, -2. The vertex, 0, -1, 1, -2, and 2, -5. Okay, that is our parabola. This has no x-intercepts. 0, 1 is not only the vertex, it's the, in this case, it's the y-intercept also. And the vertical line of symmetry is x = 0. Okay, we're out of time for today, so go ahead and sign in for attendance.